Hello everybody and welcome to a new video. In this video we will be solving more problems on Coulomb's law. It says here Mima prepares 4 identical foam beads, each carrying the same charge, positive Q. She places 1 bead at each of the 3 corners and 1 bead at the center of the square, which has a diagonal length equal to 2r, okay? As shown in the figure, what is the magnitude of the net force on the bead in the center of the square? So actually it's straightforward, although it's a long question. Let's look at this bead right here. If we want to draw the free body diagram to it, there it is. The relationship between this bead and this bead, that they are pushing each other away because they are repelling, so the force will be in this direction, okay? What about the relationship between this bead and this bead? It will go in this direction, okay? The force, this force is going to be equal to this force because they have the same charge, as you can see, positive Q, positive Q, positive Q, and they have the same distance R and R. So this force and this force will cancel each other, okay? So this force will cancel this force. But there will be another force between this bead right here and this bead right here, and also they are repelling, so it will be repelling in this direction, and there is no other force in this side to cancel it. If there was another bead here, it would cancel it and it would stay in its place, but it won't. So we know that the relationship, the force, is equal to Coulomb's constant multiplied by Q1 multiplied by Q2 multiplied by the distance squared, okay? We do not have numbers, but we have symbols, so we will use symbols. So it will be equal to Coulomb's constant, we will leave it as a symbol, multiplied by Q, which is the charge of this bead, multiplied by Q, which is the charge of the second bead. So because they have the same charge, so it's Q multiplied by Q divided by the distance. The distance between this bead and this bead is R, so it will also remain as R squared. So the answer will be Q, Coulomb's constant, multiplied by Q squared divided by R squared, okay? So let's see the choices we have. As you can see, the answer here is B, K multiplied by Q squared divided by R squared. So it's a very easy question. The repulsive force on 2 charges when they are 4 centimeters apart is 20 newtons. What will this force be if the distance became 8 centimeters? So let's do a quick drawing for this. We have, this is the first one and this is the second one. The distance was 4 centimeters the first time, and we had a force equal to 20 newtons, okay? Now, the distance is doubled, okay? It's important to keep in mind that the distance is doubled. So now the distance is 8 centimeters. What will happen to the force? First of all, we know that the force will become less. So let's look at the options here. It's important. It's impossible to be 160, and it's impossible to be 80. So we have 5 and we have 17. Okay, first of all, let's write the equation here. The force is equal to Coulomb's constant multiplied by Q1 multiplied by Q2 divided by R squared, okay? Or this time, or let's just say it's 4 squared, okay? And in this case, the force is going to be equal to K multiplied by Q1 multiplied by Q2 divided by 8 squared, okay? Now, as we can see that nothing changed here. Q is the same as Q. Q2 is also the same. But we can do the following. We can say that instead of writing 8 squared, we can say that it's equal to K multiplied by Q1 multiplied by Q2. Instead of saying 8, we can say 4 multiplied by 2 squared, okay? And we can simplify, if we can simplify it even more by saying K Q1 Q2 divided by, let's say 2 squared is equal to 4, okay, multiplied by 4 squared, okay? Now look at this, K multiplied by Q1 multiplied by Q2 divided by 4 squared. this part right here, isn't it the same as this part right here? Yes, it's exactly the same. And we know that this force or this part is equal to 20 newtons. So we can just say the new force here, the new force will be equal to 20 divided by 4, which is equal to 5 newtons. Actually, we don't need to do all that, but I needed to do it in numbers the first time. But we can memorize this. If we double the distance, this will always give us the quarter of the force. Okay, so it's pretty clear. So next time when we see a question where the distance is doubled, we don't need to do any numbers. We do not need to do any calculations. We see that the distance was 4, now it became 8, so it was doubled. We can just quarter the force. We can take the force and divide it by 4, and we will directly get the answer equal to 5. So we don't have to do all these numbers, all these calculations. This is the first time, so I wanted to do the calculations and the numbers so everything can be clear. But next time, if we see that the distance is doubled, that means that the force will be quarter the force. So this also means if the distance is halved, so let's say if the distance was 4 centimeters and it became 2 centimeters, I think it's clear that the force will be multiplied by 4. So if we double the distance, we get quarter the force. If we reduce the distance to half, we will get 4 times the force. Okay? 3 positive charges are aligned as shown. Which movement causes a zero net force on one of these particles? So we have particles A, B, and C. And it says that if I move one of the particles, I can cause a zero net force on one of these particles. So I think the zero net force will be only on point B, because it's impossible to be on point A or C, because B is in the middle, and since they all have the same charge, point B will be repelled from the left, and it will be repelled from the right because of these charges. So let's see what option do we have. Moving point A 2 centimeters to the right. So if I move A 2 centimeters to the right, the distance will become here 1 centimeter, right? And the distance on the other side is also 1 centimeter. So if the distances are the same and the charges are the same, this means that the force is going to be 0. The distance will become here 1 centimeter, and the distance also will become here 1 centimeter. So the answer is A. Each of the following pairs of electrical charges is the same distance apart. Point P is equidistant. Equidistant means it's in the middle. So point P is equidistant from the charges in each case. Okay, so we have case A, B, C, D, and P is in the middle in all times. So first part of the question, for which of these cases is the electrical force on P equal to 0? Let's look at point A. It says here that this is a positive force and this is a positive force. Whatever the charge of P is, it doesn't matter. Say if it's a positive force, it will be repelled here and repelled from this side because it's the same distance and the same charge, so the net force will be 0. So the answer will be, mainly for this part, it's going to be A. Why isn't it B? Because B, this is a positive charge and this is a negative charge, so it's going to be pulled in this direction and pulled in this direction. If it's a negative, let's say if it's a negative charge, it will be pulled by the positive charge here, and it will be repelled by the positive charge, by the negative charge here. So both forces will act in the same direction. Let's look at this force again, a positive force and a negative force. So the forces will be in the same direction, so they won't cancel each other. And finally, let's look at this case, negative Q and positive 2Q, negative and positive, they will both affect the charge in the same direction. So in these types of questions, if a point is in the middle, the only way that the force can be 0 is that if the charges on both sides have the same sign. Okay? So the answer here is going to be A. For which of the cases is the electrical force on P the greatest? Okay, so we know it's not A because A cancels the force. Let's look at B. It's being pulled by a positive charge. It's being repelled by a negative charge. Okay, well, that could be an answer. Let's look at C. It's being pulled by double the charge, and it's being repelled by double the charge. So this can be a answer. Let's look at D. It's being pulled by a certain amount of charge, and it's being repelled by a certain amount of charge. But let's look at case C here. Case C, it's being double pushed and double pulled. So obviously the answer is C. Stay tuned in the next videos where we will be covering more topics on the chapter related to electricity, and we will be talking about electrical fields. See you then.